Thanks for joining us today. We're here to talk about the future of energy, how the energy transformation will power the future. And this may be a little bit the cold water panel. We're here at Milken, and people love to talk about the future, and we're going to do that. And one of the things we're going to talk about is when the future is coming and what these things will look like in 100 years and how different or not that different from now they may look in 20 years. With us on the panel today, we have Michael Smith. He's the chairman and CEO of Freeport Liquid Natural Gas. We have Robert Armstrong. He's the Chevron Professor of Chemical Engineering at MIT, where he directs the MIT Energy Initiative. Drew Murphy is Senior Vice President for Strategic Planning at Edison International, which is the parent company of Southern California Edison. And Mark Schwartz is the Global Head of Analytic Content for S&P Global Platts, and he's the Head of Scenario Planning for Platts' Analytics Unit, which is PIRA Energy. So Mark, why don't I start with you? Can you give us the forecasting layout? Is peak oil coming? Is peak coal coming? Where do you see energy consumption going over the next 20 years or so?
Okay, well, thanks, Josh. Let me start with oil. There's a lot of talk about peak oil, and we will see peak oil eventually. The real question is where and when. In the case of the OECD countries, we've probably seen peak oil already. We probably will never exceed the peaks that we saw back in 2005. Population growth is weak, economic growth is weak. But for the world as a whole, it's a different story. If you look at what's happened the last couple years, 2015 and 2016 are the strongest back-to-back years of oil demand growth we've had in over a decade or so. Some of that may have been driven by the price decline, but even in the period where we had $100 a barrel oil and $4 a gallon gasoline, we still saw growth globally at over 1 million barrels a day. So it doesn't seem as if we're anywhere close to the peak. If we could show slide number 2, I think to understand where oil's heading in the future, it's valuable to look at where we are today and where the oil's being consumed today. If you look at a snapshot of where the oil is being used, no great surprise, 60% of it is in transportation. But if you look within that transportation piece, the personal transport, the one that's most vulnerable to where the opportunities for electric vehicle penetration and efficiency improvement are greatest, really accounts for less than half that total. Commercial transport is nearly as significant. Now, if you looked at the United States, these numbers would look a little bit different, higher weight on personal, but for the world, that's what it looks like. And then we've got air and marine. Now, we'll come back and talk about personal vehicles and electric vehicle penetration in a minute, but we expect air use of oil to continue to grow. We expect marine use to continue to grow. It's going to be tougher to slow down the growth in trucking as developing countries around the world industrialize. And the fastest growing portion of that barrel is going to be the oil used in petrochemical feed. There really aren't, we don't see any indication that the link between economic growth and plastics use has been disconnected. And we don't have the same potential for fuel substitution and efficiency improvement. The others, the stationary sources, are probably already peaked. And I would note up here, because we're going to talk about power gen, just how little role power gen plays in oil demand. It's really just a few isolated markets at this point. So let's come back to the personal vehicles. We've had a lot of exciting talk about electric vehicles, and they're coming. But I think we have to keep some perspective on the time frame. We're looking at a global new car sales of about 90 million vehicles a year and a global fleet, on-the-road fleet, of about 900 million vehicles. Last year, global sales of electric vehicles got up to about 600,000. Maybe we get up to 1 million this year. But even under fairly rapid growth of penetration in new car sales, it's going to take quite a while before we start to see a significant impact. Even if we're on a road from now up to 100% of sales by, say, 2035, the actual percentage of miles driven by electric vehicles doesn't get much over 10% until late 2020s. So put that in perspective. Put up slide number 6, if we could. Just, how do we see this all playing out? And mind you, behind this are hundreds of assumptions on economic growth and technology, and particularly on policy. We can come back and talk about that. We do think that the growth in road transport globally will begin to slow down. The use of oil in stationary uses for power gen and industrial heat is probably coming down as well. But air and marine transport globally are probably going to continue to grow, and as I mentioned, petchem is going to grow as well. So
I just want to note this is a chart of rates of change.
This is
so
a chart.
So it shows. So even though you have road transport going down, you're still using
growing.
more oil every year.
Yes, absolutely.
Yeah.
It's growing at a slower rate.
Yeah.
So the growth rate is slowing, but it's not coming to a halt. We've just started to extend our outlook out to beyond 2040. And yeah, beyond 2040, you can start to see global oil reaching a peak, but that's a long ways off. Just one final, if you could put up slide 7. I'm not going to talk about power gen in detail. We have some other experts up here. But we are expecting quite a different result for coal. We think that global coal demand, even including the big markets in China and India, very well could be close to a peak. You can see there the sharp decline in OECD use and even the beginnings of a plateau and then decline outside the OECD. In the case of natural gas, we think that it's going to continue to grow. But in contrast to oil, the dominant factor in both gas and coal is going to be electric power gen. One final point, we look at how our forecasts have changed over the years, and we've seen a significant markdown in our estimates of how much gas and coal are going to be used in power gen over the last several years. But when we look at why, the increase in renewables is a part of it, but the biggest single factor that's driven down our estimate has been a slowing down of electric load growth. So we talk about renewables, but the combination of more efficient lighting and more efficient appliances is really starting to have a big cumulative effect and something to keep our eyes on. Thanks.
Robert, what do you agree with that? Is it sort of this picture of like a relatively slow change in energy sources?
Yes, I do, and a slow shift, driven primarily by the fact that this is a multinational global industry that's literally trillions of dollars a year, and it doesn't turn on a dime. If I could have slide 8, I'd like to echo some of the points that you just heard, namely that growth is continuing to involve traditional energy sources as we go forward. And over the next couple of slides, I'd like to make 3 points. One is that, first of all, there's been a lot of political progress in the energy transition. Second, that in traditional fossil energy sources, there's been a lot of progress made. And third is that there's a lot of progress being made in renewables as we go further into the future. This is a look at what happened after the Paris Agreement, so-called COP21, at the end of 2015. And these are projections of what we expect energy use to be going out to 2100 if all of the signatories to the Paris Agreement follow through with their commitments made there but don't do anything else. A couple of interesting points here. One is that energy demand growth increases very substantially, a doubling of energy use by end of century. We're still dominated by fossil energy sources, 75% of our energy from oil, coal, and gas by mid-century. So even though there's fantastic achievement at COP21 with 195 countries signing on, there's a lot more we have to do to reach climate goals going forward. If I could get slide 10, I'd like to switch then to what's happened in the fossil energy industry. There's some really stunning changes that have happened in this industry, completely unexpected, going back to 2005 or so. Namely, what's happened in shale gas first and then shale oil. Back in the early 2000s, 2000 to 2005, U.S. domestic production was essentially all conventional gas. It was declining. We expected to be increasing ever larger amounts of natural gas. We were building lots of LNG import facilities in the U.S. What you see here is the result of research progress and work in industry to improve horizontal drilling technologies, fracking technologies, and dramatic growth in shale gas production. The big light blue section near the top there is one of the shale plays alone, the Marcellus shale play, which accounts for 6.5 TCF, trillion cubic feet of gas a year, more than Iran, more than Qatar, more than Canada produces. A huge field. And we just now have the Alpine High field in West Texas coming online, which may be the biggest field in the world. So that's had a tremendous impact. I think you'll hear more about the impact that this gas resource has had globally. But the picture is not limited to progress in traditional fuels. If we look at slide 11, that looks at the progress that's been made in renewables. Back in 2005, there was some 80 gigawatts of solar plus wind installed around the world. By 2015, we were up to 562 gigawatts of solar plus wind. And the projection is that in 2021, we'll have 1,265, I think it is, gigawatts of solar plus wind. And for the first time, the projection is that there'll be more solar capacity addition globally than wind addition globally. That's occurring at the three scales I illustrate there, at utility scale, where most of the capacity is added, at commercial or industrial scale, and then also at residential scale. The next slide is slide 12, and the next slide are going to illustrate what some of the bumps in the road may be as we make this transition to solar. In particular, this slide looks at what happens to the price, to the value to the asset owner you get as you get more and more solar penetration in the grid in the absence of storage. Right? We're starting to see storage added to the grid now, but currently there's not a lot, and so this is the situation we face today. And what you see is that the more solar penetration I get without storage, I get more and more zero marginal cost energy in the middle of the day, and that ends up driving down the average market price, but the value to the asset owner, the solar asset owner, drops much more rapidly. So that even though solar prices are decreasing very rapidly, they're going to need to continue to decrease to compete in this continued solar penetration. Slide 13 looks at another challenge that faces us. This is a look at how we meet energy demand in a region, electricity region like Texas. This is a model of ERCOT, which is the Texas grid. We picked that. A lot of people model in ERCOT because it's more or less an isolated energy system for electricity. The very top curve there is the total load in the system on a typical summer day. The yellow band is the part of that load that's met with solar, and the brown piece is the part of the load that's met by everything else, so non-solar generation. And the four different blocks there are different amounts of solar penetration. Far left is about 12% penetration of solar, and going all the way to the right, more than 50% solar penetration. 2 points I want you to observe from these slides. The first is that the non-solar generation capacity doesn't go down once you get beyond about 12%, 10 or 12% penetration. And the reason for that is that in the absence of storage, all of that solar resource is concentrated in the middle of the day. Right? So I still have to have the same amount of non-solar generation in the system, but compensation for it gets more and more difficult. That's a challenge for policymakers. Secondly, is that the ramping requirements on that non-solar generation get more and more severe, and we need new ideas and new solutions there.
Can I interrupt you before we go to the solutions? I want to ask Drew about this problem, because this is a problem that you must have to deal with all the time, running an electric utility in a part of the country that I think is relatively enthusiastic about alternative energy. How do you guys deal? Can we put that slide back up, the slide 13? As people install solar in their homes, how are you guys dealing with this? And how are customers dealing with this as they, there's no demand for the excess energy they're producing in the middle of the day?
Yeah, no, well, it's obviously it's not exactly what California experiences since they're modeling ERCOT. But if you actually look further to the right on the chart, we're now in California closer to that 36%, say, heading obviously towards 50% at some point of renewables, and a lot of it's going to be solar. So for those of you who are familiar with California and the work that's being done here to try to address this, that's the duck curve essentially, which is what we're facing, where there's a lot of renewables in the middle of the day, particularly solar, and then as you get to the end of the day and the solar comes offline, you've got to be able to ramp up other generation, or now increasingly have storage in place to try to deal with that. So from the standpoint of the electric power sector and the industry that we're in, we're sort of focused on addressing this in a couple of ways. One is, I would say, in California, we've got the overlay also of having to now head to a higher greenhouse gas reduction target than any place else in the country. We've got a goal of reducing greenhouse gas emissions in California that's now signed into law. We have to get to 40% of 1990 levels by 2030 with a potential heading towards 2050, an 80% reduction by 2050. So that just sort of is an overlay on top of this renewables problem. But to answer, Josh, your question specifically, we're focused really on essentially making sure that the grid is going to be there as the main asset to help deal with this problem. So we know that what we got to do is actually spend a lot of money upgrading the grid so it can accommodate a lot more types of resources, because a lot of the solar is out in bigger solar projects, utility scale, that's tied to the grid and the wholesale level, but a lot more of it in our territory and others is going to be also on people's rooftops, businesses, homes. We now we're doing basically 5,000 requests a month or so for rooftop solar, and that's just increasing. So we're looking at how can we make the grid more robust? How can we actually make sure we've got the technologies out there that can make sure that all of these resources are communicating so that we can actually deal with this quick ramp rate and needing to control the grid more dynamically. It's not how it was designed originally. It was sort of a one-way power flow grid, and now we're actually having to make our distribution system more two-way, more of a network. So we're looking to invest billions of dollars over the coming next 5 to 10 years in actually trying to provide that modern capability. A lot of it's going to be communications and technology, data technologies that will allow us to communicate like that. And we also think that storage is going to be a big part of it. So we're just in the early days of adding storage to our system. We've signed now contracts for about 400 megawatts of storage in the Southern California Edison territory. That's a combination of various types of resources, mostly lithium-ion battery technologies that are configured on the grid in different ways. Everything from putting them at our peaker plants, which we've just done a project with GE for 2 of our peakers for 20 megawatts, where we're actually going to make the peakers, which are the gas-generating turbines that come on really fast to do that ramping. We're going to make them more efficient and actually be able to ramp faster by having storage there co-located with them so we can have more instantaneous response. We've also got projects with our customers who are putting battery storage on their sites, and we're aggregating those battery storage projects together to provide sort of local storage so that we can help address some of this problem. So there's a variety of these things that are happening. And but really at the end of the day, we see our role as providing the grid, the network that can make sure we can connect all of those things together, that we can give customers the choices that they want when they want to put solar on their roofs, or the Public Utilities Commission tells us to go out and buy more solar from the larger projects. And then to the point, the EV forecast, well, I agree with Mark that it's a long ramp rate, and to actually switch out, sort of the whole fleet will take many, many years. We believe because of the carbon goals we have in the state and because of the efficiency that you can get by electrifying more and more parts of the economy in terms of both just dollars and cents efficiency, but also air and quality and climate efficiency, we're going to have more and more electric transportation and electrification of other uses. So that's going to be another place that our grid is going to play a very important role as we look forward out the next 15 and 20 years. So that's sort of how we see it.
Okay, great. Michael, so people sometimes talk about natural gas as a bridge fuel. The question is, how long is the bridge? What do you see the trends being, and what do you see the role that natural gas is going to play over the next coming decades?
Well, just looking at the slides, if you looked up here, I'm looking down there, the slides were clear, very, very clear. The demand is increasing worldwide. Natural gas is growing greater than any other of the fossil fuels, and for good reason. It's the cleanest burning fossil fuel, and it will be either the bridge to a totally clean environment, or it's going to be there for as long as the eye can see, because we're going to need technologies that don't exist right now to be able to supplant natural gas. And the outlook for natural gas for the next 20 years worldwide is absolutely fantastic. I looked at those slides and I said, if I was public, I'd buy my stock. Can you put slide 10 for a second, his slide? So this is about transformation, this panel, and I'm all for electric, but you got to really understand what's happened in the United States, how transformational it's been in the last 10 years, 8 years. At the beginning of that slide is 2005. The natural gas was declining in the United States. I started construction January of '05 on $1 billion plan to import natural gas. It's been running for 9 years. It's never been used because we didn't know that we could develop shale. And that shale that has increased, we've increased our production from less than 50 billion a day to up to 77 billion cubic foot of gas per day. And most of that's being used, the increase is gas-fired electrical generation and for petrochemical, because the prices got low enough for the factories to use it again. And CO2 emissions in the United States has gone down 6 consecutive years to the lowest level it's been in 7 years. So there is a benefit for using natural gas. And for what we're doing, we're now building a $13 billion LNG export facility to take all this excess shale gas we have in the United States and to turn it into LNG by supercooling it to minus 260 degrees Fahrenheit. It takes the gas from a gas to a liquid, and it shrinks from the size of a beach ball to a ping pong ball. Then you can put it on a ship that are huge ships, sizes of the biggest cruise liners in the world, and they're floating thermoses. All that there is insulated because the stuff wants to go back to its native form, natural gas, and expand again. It goes to countries that doesn't have natural gas, the largest being Japan, the largest importer of LNG in the world. When we do that, we displace coal around the world. So our natural gas that we have an abundance of in the United States is not only making a difference in improving the environment here in the United States, it's making a difference worldwide, improving the environment. So I think it just has a tremendous future.
So I guess one thing that Michael and I were talking about before the panel was sort of the associated sharp drop in natural gas prices with this sharp increase in production. And I guess I think about why do people buy energy from renewable sources? You can sort of have like three major reasons they might. One is it's they find it's the most economical source. One is the government causes them to do so in one manner or another, and a third is that they feel a moral imperative to do so. And I guess when you look at your customer base, what are you seeing as the mix of those things, and how much does it matter for people as they do solar installs at home? How much the economics of that change, either because they can't sell the energy for as much because there's a glut of solar in the middle of the day, or because cheap natural gas has made other sources more attractive?
Yeah, I mean, and maybe if I can focus that question a little bit on, because we like to talk about sort of individual consumer behavior, and that's important. But I think that what you're seeing is that actually large commercial and industrial customers are really driving an interesting trend here. So they actually use a lot more of the energy across the U.S., especially now increasing renewable energy than sometimes individual consumers. So we're seeing that those three sort of motivators that you've outlined have now flip-flopped in essence. So if you look back, 15 years, 10 years ago, obviously what we would say is government policy through the form of subsidies, renewable portfolio standards, tax subsidies, all those, were one of the key drivers to get sort of economic behavior out there or to force people, as you say, to buy it. But what's happened, as I think most people know, is in the last 10 years, we've had this significant unexpected decline in both the cost of wind power and now solar, which has even come down faster. You've had these sort of 10x sort of decreases over that lifetime of the cost of installed solar, to the point where solar and wind in some places now compete on economics alone without sort of the RPS or the other subsidies. That doesn't mean that we aren't still seeing the need for, and some of those things exist, and we have to sort of transition to that period. But I guess I sort of might make a point that one of the interesting things about what Mike just said about natural gas, which I think there's an analog in renewables for, is that, because I was in the power generation business in a traditional power generator in 2005 and 2006 when this was not seen. We did not know that was coming. I sat in board meetings and meetings with management looking at our natural gas curves, seeing $12 natural gas, and looking at those, quote, unconventional sources of gas, and they were teeny and they were too expensive to actually exploit. So the fact that this has happened and flip-flopped everything in natural gas is transformative, but we're also seeing something similar, I think, in renewables, and if you play that out, I think we make sure that we don't discount the transformative impact of that on folks too. So just one of the projections we look at from Green Tech or Bloomberg is we're going to have over 60 gigawatts of solar built in the United States in the next 5 to 6 years. That's a significant amount coming online. It will still mean we'll need natural gas to also provide some of the backup and the ramp, but the growth in power generation is coming from segments that we didn't even expect 5 or 6 years ago. And back to the point you asked about is customers are now doing it for all three of the reasons you said, partly because there's mandates, but also because it's economics, and also more and more because they also want to do the right thing for their customers, for their employees, for their organizations. So we're seeing a lot more of our customers in our unregulated business signing up for on-site solar and now off-site solar and wind projects because it makes sense economically. They want to be sustainable. And here's an interesting thing they're also beginning to realize is that gas projects and other places that they get their traditional electricity have a lot more volatility. When you start getting to zero marginal cost projects like solar and wind are, you can take the fuel volatility out of it. You can sign up at the beginning and fix your costs up front for a 20-year or 10-year period. And that's an interesting thing to talk to a CFO about. That's a hedge that they didn't have before that they're looking at.
Mark?
Yeah, let me just add, I think it's not necessarily in the U.S. a question of renewables or gas. We still use a significant amount of coal to power power generation. It was 50%. It's coming down to a third, but still, there's a lot of coal retirements likely in the next several decades. We may see nuclear retirements as well. So, there is a world where we can continue to see the strong growth in renewables without it necessarily coming at the expense of gas.
Right. Let's talk some about vehicles and sort of what the likely growth path is there and some of the challenges. I know that I think both Robert and Mark at least had some thoughts about this when we spoke before the conference. What stops people from buying electric vehicles?
Well, right now, cost. Right. Mm-hmm. So electric vehicles are expensive and suffer from challenges of range anxiety with customers. There are concerns about charge times, although there's progress being made on both of those. To give you a sense of the price issue in Norway, the subsidy for Teslas, for electric vehicles, mostly Teslas actually, is about 23,000 euros. Right, which is pretty good subsidy if you can get it.
And they have a big tax on gasoline-powered cars as well, right?
That I don't know.
Okay. Well, that's the kind of nature of the subsidies. They're forgiving to get
right. Okay, I see. Yes. Yeah.
So there's the challenges on electric vehicles, those are being worked on for sure. But there are other technologies out there that can help you get to where you want in vehicles as well. So more efficient gasoline spark ignition engines, so better fuel engine combinations. There's a lot of progress being made in other engine technologies. There are ideas for hydrogen fuel cell vehicles. Toyota's working very hard on those kinds of problems. And then there are systems challenges, I think, that are out there for any of the new technologies. So those include the infrastructure for charging or infrastructure for hydrogen refueling. So I think there are challenges there, and as I think was mentioned earlier, I think given the size of the fleet and how long customers tend to hold their vehicles, at the soonest you wouldn't see a full turnover for about 15 years.
Is there progress on those issues of charging and range? I mean, one thing that seems relatively inconvenient about electric cars is not being able to have the experience of refueling the car in 2 minutes.
So if I could just sort of to frame the challenge, so what you get with a gasoline engine when you're filling up the car, I calculate I have about a 15-gallon tank. It takes me about 3 minutes to fill it up. The power into the car through that fuel is 12 megawatts. Right, which is pretty hard to match. Now, to be honest, with an electric vehicle, the electric engine is more efficient than the gasoline. You don't need as much power on board, but that's a big challenge to have the same convenience of charging or refueling as you have with a gasoline fuel.
Mm-hmm. Josh.
Yes.
I'm in the gas business. My kids drive Teslas.
But do they drive Teslas because it's practical or because it's cool? I mean,
because it's electric is number one, and it's a beautiful, incredibly well-designed car that I wish it was a little bigger so I could fit in it better.
Well, let me just address that. As a Tesla owner and as a 2 electric car household as well, the things, I mean, look, we all know that the cost is one. Clearly, that's all really the cost of the battery. So battery costs are projected to continue to come down at something similar to the rate they've been coming down in the last 5 years. So, you know, and as you scale production, which is what obviously Tesla with Elon Musk are trying to do, you know, we think that we can project the cost curves beginning to cross over fairly quickly. So the behavioral issues are actually just as significant. And to your point, so you got to get more DC, the fast charging, the sort of what they call level 3 chargers out there for places where people are on the road. And that's something, again, Tesla and others and the automakers are really focused on deploying that. But the interesting thing for most people, and you've heard these statistics, most people, you know, in their daily lives, 80% of the time they drive, they only drive like 20 miles and not more than that. They're driving very similar routes. So once you get something like, you know, the Tesla-sized battery or the one that's coming out in the Bolt or others that have where you can get 200 to 300 mile range, that range anxiety for most of the time, most of your trips doesn't matter. And then you're basically able to leverage an existing, I'm talking my own book here, infrastructure system, which is the electric power grid, and without a lot of extra cost, leverage that to get faster charging. So at home I use a level 2 charger, which is basically like, you know, the thing you plug your dryer into, and it's pretty easy and not too expensive to get somebody to come in and wire that up. And so we're trying to figure out how to get more of that out there so that everybody can charge where they normally leave their car sitting most of the time. So there is a challenge there. I mean, but I think, you know, each of those are being addressed, and you can see a path towards addressing those with existing technologies and the existing cost curves that are coming down. Then it's a matter of how quickly can you get, you know, the automakers to actually be willing to make the cars so that at a price point people can enter on.
By the way, I heard earlier, it's going to take a long time, the numbers that you brought up.
Absolutely.
I mean, 90 million cars. I mean, if you get 10 times the 600, you're at 6 million cars, and that's basically, you know, you've got 7%, once you get 10 times what you're doing today. So it's going to, it's a fast ramp up on a low base. But impacting worldwide energy, unfortunately, we're still stuck with hydrocarbons for my lifetime, and hopefully my kids' lifetimes will start tapering down.
Yeah, I mean, look, there's a huge range of uncertainty about the technology, certainly around the policy and the extent to where we're going to see subsidies in the U.S., whether China puts on aggressive targets, whether India is now talking about aggressive targets. The good news for all of you out here who are investors is it really shouldn't catch you by surprise, because for these the slow nature of first you're going to see these things begin to penetrate new car sales, and you're going to see how it reacts when the subsidies come off. And you're going to see whether or not these international targets are really met, or, as we've seen a few times, the countries continue to defer the targets as they get closer. But it shouldn't catch you by surprise. You should see this trend emerging years before it has a major impact on either gasoline demand or electricity demand.
Well, so you mentioned policy. How much should we concern ourselves with policy? And in particular, Donald Trump got elected president talking about bringing back coal. And I think that's one of the things that we're not quite taking literally. But there's been this there's been this sort of dissonance in how people talk about Donald Trump and carbon emissions and and emissions policy and energy policy, where there's one narrative that's basically like the sky is falling and he's going to undo everything and he really is going to bring back coal and it's it's going to be black soot into the sky. And there's another narrative, and Mike Bloomberg has been writing, well, so much of the train has left the station on so many of these things, and the trends are long run trends, and it's not, his election and whatever policies he makes in the next 8 years don't actually matter that much. So which of those is right? Does Donald Trump's election and more broadly do political trends matter for these outlooks?
Well, I'll jump in on just the local person in the room with California, the 6th largest economy in the world, by the way, and say that as I said, we're committed to 30%, 40% reductions of 1990 levels by 2030, going down after that. So when you look at that, when you look at the other states that have similar renewables and climate objectives, you look at the cities in the U.S. and globally that have committed to climate change goals, and I think Bloomberg and Pope make this point in their book. And you look at the large multinational companies that have also done the same thing, again, for both economic and sustainability reasons. My view, I think in our view certainly at Edison, is that yes, you'd like to have alignment with the federal level. The truth is the federal government has never directly had a huge hand in energy policy. I mean, we've been trying to have a unified sort of federal energy policy for years, and it never really happens. There's places where they play. But I think on these issues in particular, we do think the trend is, long-term trend is still going to be there. And, yes, there will be something around the edges that will impact that. I would say the one area that we've been talking about where there's probably the most direct impact, or two areas, I would say. One is electric vehicles and vehicles generally, because they set, setting CAFE standards and setting fleet emission standards does drive a lot of the efficiency of the internal combustion engine, as you said, Mike. So, I mean, depending how efficient they are, that can make a big difference. And I think the other area that really makes a big difference is in what I would call project permitting. Probably, that's something where if they do what they say, they could actually help the energy mix. Things move faster because we could have energy projects and infrastructure for energy move faster than it has in the past. There's possibly a good news.
And so that's all kinds of energy infrastructure. That's electric grid stuff and pipelines and
transmission lines,
production.
pipelines, any major facilities. Generally, there's a federal aspect to permitting around it, I think.
I don't think any corporate CEO is going to go to final investment decision on a big, huge coal plant because we have a current president who likes coal. I mean, these decisions are 30 and 40-year decisions on these massive plants. So those who continue to need additional sources of generation are going to continue, I believe, on the path they're current, which is a clean, gas-driven model and renewable. I do think that the negative for our environment will be that there is a scheduled retirements of lots of coal plants. You guys know the numbers off the top of your head. And it's gone from 50% coal to 35%, and it's scheduled to continue to go down because of all these retirements. And those retirements would be replaced by clean burning natural gas, or cleaner burning natural gas. Could always postpone it till the next president for another 4 years or 8 years, and there is no cost to that to that utility for capital. Capital's already paid for the plant. Every year he gets to run that thing. He's got no capex going out on his new facility. So.
But were they?
That's a potential negative. I don't know how it will shake out.
Were those retirements happening because of public policy or expectations of public policy, or were they happening because it was just expensive to do the coal generation?
A, they were getting old, but B, public policy has done an amazing job in the air quality regulations, and that's been happening not just during the Obama administration. That happened in Clinton, that happened in Bush, that happened in Obama, even more so.
But it was also natural gas prices. I mean, to
Yeah.
this curve we saw earlier, I mean, when you're at $2.50 or $3 an MMBTU, your coal plant is not going to run the same.
But if you look at that curve, we were growing our production, and gas was still $5 during that stage. I know in 2009, I commissioned my facility, and I had to pay $12 an MCF. The one time I had to buy gas to start up my facility, it shot up to $12. So it wasn't all that, but that's a major incentive to go burn natural gas.
But fundamentally, I think it's an economic challenge. And sadly, the challenge is not just to coal. So cheap gas and renewables are also impacting the nuclear fleet in the U.S., which is a zero carbon energy source, which can serve as base load. Exelon had planned to shutter 2 perfectly good nuclear plants in Illinois back in 2016. I guess in December, the legislature put together a set of new policies to enable those to keep running. But there are a number of states that are having to grapple with that issue. How do you put the right financial incentives in place to be sure that you don't run into Germany's problem, right? Which is that by shuttering nuclear, moving to a lot of solar, but backing it up with coal, you end up with carbon emissions that go up instead of down.
Well, I'd just add, the other place where we have debate about energy policies on the upstream side, on the production of oil and gas. And sure, if there's less regulation and more leasing at the margin, you could see a little bit more production. But as we've said on gas, and you can show a similar chart on oil, we've had record historically high expansion of oil and gas over the last 10 years. And you just wonder, and we're already going back to 1 million barrel a day growth in oil production by the end of this year. You just wonder how much faster the industry can go without starting to see some overheating and some shortages, et cetera.
Well, and Mike, you'd been saying before the panel that part of why you didn't expect that big a difference from policy changes was that the Obama administration had been more friendly on oil and gas production than a lot of people think of it as being.
Yeah.
Or is that not how you want to put it?
Look, they were as great an environmental steward as we ever had in the White House, no question about it. We're all talking about fracking, and fracking created that. It's like fracking. It's the misnomer. We've been fracking wells for 60 years. Right. It's directional drilling and then fracking. So, but people don't realize that when you drill, if we had a rig right here and was drilling a well right here for whatever formation for years, we go through, find our formation. It's 50 feet thick. It's 200 feet thick. We put it behind pipe. We perforate it, make holes in the pipe, and then we frack it. We've been fracking wells for 60, 70 years. The frack that we would do would probably go out 500 feet to 1,000 feet around the hotel, and it would drain the oil and gas around that well. Well, now, you know what we do? We go down to that 50-foot formation, and we make a right turn, okay, horizontal, and we go all the way to the 405, okay? And we go 10,000 feet or 12,000 feet. And then we put pipe in the hole. And then we perforate 12,000 feet or 10,000 feet. And then we do the same fracks we've been doing for 60 years, but we do 60 or 70 of them because there's 12,000 feet of them. Yeah. And what happens? You end up with production that's 100-fold, 200-fold more than any vertical well. And that's what U.S. technology has done and has reshaped the entire world of energy. Obama studied this like crazy. A very tough EPA studied fracking like crazy. If fracking was dangerous, we would be shut down. They did not find anything, and they supported it. So there's nothing I see Trump doing that's going to be worse than that. So I wouldn't call Obama administration friendly to oil and gas. They reap the benefits. The U.S. economy.
We get slide 12.
Yeah, the U.S. economy would not be.
Sorry, slide 10.
The U.S. economy, for his 8 years in office, would not be the same if we didn't have fracking and you took away the 4.5 million barrels of oil that we're producing more now. We would have $125 oil. Yeah. If you took out that gas, we would pay $12, $15 for our natural gas. You talk about the economic hardship around the United States. We wouldn't have a growth economy of 2%. We'd be in recession if we all of a sudden had to pay those. When you talk about energy transformation of what the energy industry has done for our country, it's the greatest gift, economic stimulus that Washington could ever dream of.
Mark?
Sorry, just one follow-up point on the regulation. By and large, the resource base, the tight shale gas resource base, is not on federal lands. It's on state lands, or it's on private lands. So the lead in regulation has really not come from the federal government. It's come from the state of Texas and the state of Oklahoma and the state of North Dakota. So yeah, I mean, it's room for the federal government to step in and, for methane capture and things of that sort. But by and large, the primary responsibility for regulating this has been with the states.
I want to talk a little bit about the far future, and I know, Robert, you had some ideas about things that, 50 plus years on, maybe transforming this, or sooner than that, I don't know.
Sooner than that, I hope.
Okay, sorry, not within 50 years. What's going to change all this?
Well, so if we could look at slide 14. So I wanted to go back to the slide that I showed that showed the challenge on solar prices and the need to have ever decreasing cost for solar. So how could we learn to make solar cheaper than silicon, easier to install, easier to manufacture? Here are some new ideas. This is an example of the lightest weight solar cell ever been made. This is made by printing on a flexible substrate. It's a polymer substrate. That's a solar cell floating on a soap bubble. Don't think commercially you'll ever install these on soap bubbles, but it would work. So that's an example of the new kinds of chemistries for photovoltaic materials that scientists around the world are looking at, and new ways to manufacture and ultimately deploy that offer much lower cost. Second challenge I pointed out was storage. So if we look at slide 15, it's an example of a cheaper grid-scale storage. The storage challenge is actually multidimensional, and there are lots of different time scales you need to be able to store for. Very short time scales for frequency regulation, voltage control, and very long time scale storage. This is an example of a battery that uses liquid metal components for the electrodes and electrolyte. It was basically inspired by an aluminum smelter, which is a materials processing device that consumes vast amounts of electricity. You only find these smelters around hydropower plants or other really cheap electricity sources. Don Sadoway, the professor in this picture, had the idea of developing something like that, but that he could run frontwards and backwards, right? So he could take up large amounts of electricity from the grid when there was excess solar midday, and then put it back out onto the grid, say in the early evening hours when demand was greatest. That promises to use really, literally dirt cheap components. It's made of dirt. And then the last example I'll give is an example in slide 16, an example of what might happen in waste-free baseload energy in the future. This is a look at the future of fusion power. So fusion, that's the stuff of the sun. I know you all know the joke that fusion is the energy of the future, always has been, always will be. I'm here to tell you that may not be the case. So when you're thinking that, you're probably thinking the International ITER project, which is under construction now. They're a demo facility just outside Marseille, France. They expect to be up and running with their first heat test by 2026, 2027. I think first power test 2036. Who cares by then? This is a look at new technology. There are a number of groups around the world. This particular idea is out of MIT, which was involved in developing the magnetic confinement for the fusion of plasma that's being used at ITER. So it's the same physics. But this technology uses newer superconducting materials developed since the ITER design was locked in. The virtue of that is that you can go to much higher magnetic field strengths with these superconductors. The fusion power scales like the fourth power of magnetic field strength, which means you can nearly double the magnetic field strength. You can get a factor of 10 reduction in the reactor size. And that's a real game changer for how you design it, the cost, a lot of other issues. The group at MIT thinks they can have a heat test, well, first a magnet test within 3 years. If the magnet test works, then they have a clear sight line in 5 years to a heat test, 10 years to a power test, which would be a true game changer. And if the magnets work as they believe they will, it could also affect a lot of other businesses, like magnetic imaging in the medical field. So there are a lot of things that could come out of this that are side benefits, but fusion may not be so far away as we're used to thinking.
And so the idea is this will be at a scale such that you can get more power out of it than goes in?
Yes, for
I
sure.
mean, well, yeah, I mean,
yeah.
I
So
guess
the idea is
that's
that
the ballgame,
within 10 years, right,
Yeah.
they expect to produce net positive power.
Maybe if I can just jump in there, because I think it's really interesting that Mark is pointing out three really critical ideas and areas, especially talking about storage and solar, where research and development is hopefully going to drive new technologies and drive costs down and give us additional functionality. The thing that people don't always realize is that the electric sector, unlike the oil and gas sector, because of the way we're set up and where we're regulated, we spend very, very little of our revenues on research and development. I'm not going to remember the exact number. It was something like 2 to 3% for the electric sector, including what we sponsor ourselves through EPRI and other organizations. Most industries, your traditional industries, that's 8 to 10%. Some of the industries like pharma and high tech, much greater percentages are in RD&D. We have to change that. And one of the areas, we're back to your politics question, where I think the current administration will have an impact, is that much of the research and development that has been done in the electric sector has been done through organizations like the DOE, all of the national labs that are funded by the DOE, and if we cut back on that, the ability to make progress, I think in the electric sector in particular, will be set back. And I don't know about these projects at MIT, but a lot of the academic institutions, the only way they're able to do this kind of thing is by leveraging federal funding as well through DOE and other projects. So I just say that because there's a lot we can do. The electric sector, and again, the grid exists. It's already an asset that's there. It's one of the most efficient ways to actually make this kind of leap that we need to do going forward, but we've got to focus on how we're going to actually get to the next generation of technologies.
Absolutely right. The grid scale battery I showed a minute ago was actually, we seed funded it as a small project within the Energy Initiative at MIT, but after the seed project, it was funded to go up to scale by one of our industrial sponsors and also by ARPA-E. It was the very first round of ARPA-E funding. That kind of work that ARPA-E does and that other DOE programs do are absolutely vital to see us develop these technologies that we need to fill in the gaps in a zero carbon future.
On that note, I want to take a few questions from the audience. We have a couple of folks who will come around with microphones, so hold up your hand and then you can wait for the mic to come to you. Let's start with this fellow in the second row. Oh, here's the mic coming.
Just a question around oil prices, and if oil goes back to less than $30 a barrel, would we see U.S. shale gas at the current levels continue, or would that production contract? And then secondly, what would that do? What's your view on global gas prices and whether or not, for the first time through this shale gas revolution, we've seen a divergence between oil prices and gas prices forever?
Well, yeah, certainly if we saw crude prices go down to $30 a barrel, we would see a contraction just as we did in 2015. And probably that would pull gas production down as well. And we're actually at a situation where we're getting more and more associated gas coming along with the oil drilling, especially as we go into the Permian. The one interesting thing, and I'll raise the question too, the LNG market is moving away from its traditional markets in Japan and Korea, Taiwan, Europe, and the future is going to be to a greater extent in China and India and South America and maybe some smaller markets. There is an argument that you probably can't gain the inroads that you need with oil index pricing for a long time. You really have to be competitive in power generation.
Yes, in the middle there.
No matter how you slice this future, it's going to involve electricity is the intermediation. You're going to make a lot more electricity in the future, and you're going to distribute a lot more electricity. This raises the issue of the security of the grid. The whole economy is going to become ever more dependent on the security of that grid against hacking, against natural disaster. Are we even close to ready for that?
Drew, are you preparing us for that?
Well, personally, actually absolutely focused on it. The industry is very focused on it. You're absolutely right that both from a cyber and a physical standpoint, grid security is something that has been a focus for the last 20 plus years. More and more effort being put into cybersecurity now as we see the ramp up of obviously cyber incidents, and so that's something that I would say the industry together with the federal government very focused on doing. We have a significant amount of our investment in terms of time and resource looking at how to make sure that when we connect all of these different things to the grid, we're doing it in a way that actually doesn't increase the risk, but actually decreases it. And there's some theories by which having some more distributed types of technologies and more distributed controls will actually help that, because we'll move away from some of the centralized stuff that if you get to a centralized place, you can actually affect everything. So we're looking at the network effect actually being a positive in some ways if we get the technology and the cyber piece of it right. So huge focus of what's happening in the industry right now.
Yes, sir.
A question on carbon pricing and cap and trade specifically for California. If it continues, is it having the intended consequences, and do any of you see this becoming adopted in other states?
I'll start on that maybe. So I think it's still, we have seen progress in California with the existing cap and trade program, and I know there's debate going on actually literally right now in the state Senate and the legislature about extending that and looking at whether we need to change the floor pricing and other things. So the program needs to be continued to be modified, but I think there have been benefits. It needs to be extended significantly if we're going to match it up to the 2030 goal. And I think that we're very supportive of that happening. We think that needs to happen to make sure that we've got one of the mechanisms in place to actually meet those greenhouse gas goals.
I'll add Massachusetts has a carbon tax or fee, revenue neutral, in front of the legislature right now. There are similar bills in Rhode Island and Connecticut tied to the Massachusetts program, so that might come to pass over the next year. But I'll also like to add that I think this is a place, carbon pricing, carbon tax in particular, is an area where the federal government really is needed. States can do a lot, but one of the things they can't do in a carbon price is include a border adjustment clause. And if we had a national carbon tax with a border adjustment clause, that could go a long way to putting a price on carbon globally in a fairly short period of time.
Yeah, I would look. The market can work wonders, but it needs a signal. once you give that signal, and the carbon price may not have to be that high, I think we will be surprised at the magnitude of the response we get, but you've got to put that signal out there.
But don't you think that has been put on the shelf for 4 to 8 years?
We've been, in our long-term outlook, we have to make an assumption on U.S. carbon pricing, and it's been 5 years from the current time for the last 10 years now. So it isn't just now. I mean, it slipped
That was
even under
before
the
you had
Obama
Trump.
administration.
But maybe you need a
Now it
revenue
slipped even
stream
more.
for reducing corporate tax, right?
Yeah, I don't.
All sorts of
There are a
possibilities.
number of deals that Donald
Horse
Trump
trades,
floats
yeah.
as possible. I don't think that one's going to come to fruition. That's all of our time today. I want to thank all of you for joining us. Thanks.